Hey, so this is a little bit of background in why we're doing what we're doing in 3.2. Our goal in 3.2 is to be able to solve equations that aren't very easy to graph, maybe something like 2x plus 3y equals 17, and let's see, 4x plus y equals, it doesn't really matter. I'm just going to throw numbers in here. I'm not really going to solve this right now, but I want to talk about why we do what we're going to do. The reality is that there's two different ways we can go about solving these. The problem with these equations is that they're not very graph friendly when you think about doing things like dividing by that 3 next to the y. When I do that, I'm going to create a bunch of weird fractions. The numbers aren't going to come out very pretty in terms of graphing by hand. Now, we talked last time about graphing using calculators and different software programs, and they have done so much for us that even some of these approaches don't seem like they work well, but even those have a breakdown. Most graphing utilities don't do three-dimensional graphs, which is an issue that we're going to have to address in 3.4. We also have issues that a lot of graphing utilities can't graph circles very cleanly or very well. They have to be redefined in order to graph circles and other shapes like sideways parabolas and things like. There's a world of geometries and graphs that are just difficult to work in a two-dimensional traditional form. So we want to have other ways around. There are problems that are difficult to graph, and when that happens, even with a graphing utility, we want another option, and this is where our other option comes in. It's also a really good practice or exercise in paying attention to details, thinking steps through, 3 or 4 steps ahead, really trying to plan and then execute that plan. Those are life skills that we definitely want to develop as part of our Algebra 2 content. So the idea that we're going to deal with here, I'm actually going to take those two equations, I'm going to ignore them for a minute. Let's talk about some really simple ideas. Let's say that I had y equals 5. Let's say I know that y equals 5. And over here I have an equation that says x plus y equals, I'm going to get rid of that, equals 15, okay? Now, we can kind of logically think our way through this and try to come up with what we think x is. But we could also do the formal process of substitution, which is to take what y is equal to in another equation and substitute it in place of that y in our other equation. So here that would look like x plus, instead of writing y, I'm going to write something equivalent to y. In this problem, that would be a 5. Now if that equals 15, suddenly this is extremely easy to solve for x. That's our first method that we'll talk about in class. For instance, if you look at the second equation here, if I solved this for y, I would get something like y equals 23 minus 4x. That something that y is equal to could be substituted into the other equation where the y is. By doing that, I'm replacing something I don't know with something that's better or easier to understand. And the big principle that this pops out for us is we would get 2x plus 3. Instead of y, I put the 23 minus 4x. That's the substitution. Equals 17. The big payoff in doing something like this is that now there's only one unknown letter in this equation set. I can solve for x, and then from there I should be able to plug in and find my y. So that's the logic or the theory behind this, that if we take something equivalent to our y value or to our x value, we can plug those things in. This is called substitution. The other type of problem that we're going to approach is more based on this concept of what we call elimination, and it's usually used when substitution doesn't work well. For instance, if I have 3x plus 7y equals 18, and I have 2x minus 4y equals 13. Let's just say those are my two equations. right now, if you tried to solve for x or y, like we did with the substitution problem, you're going to have to divide by some number no matter what. They all have a number in front of them. That makes substitution more challenging and difficult. You'll have to deal with fractions along the way. It's just not going to be very pretty. It makes the algebra harder. So we're going to try something else instead. And here's where our logic comes in. Pick any equation you want. Let's say 2 plus 3 equals 5. Let's pick another equation. Maybe 6 plus, well, let's go with 6 minus 3 equals 3. Okay, we know this is true, correct? These two equations are true. If we combine the left sides and the right sides, which is addition, we add them vertically, 2 plus 6 is 8, 3 plus a negative 3 is 0, so that'd be like 8 plus 0 equals, and 5 plus 3 is 8. We end up with an equivalent equation. And this idea of canceling one of the terms is hugely beneficial when it comes to using this elimination method. Both substitution and elimination are focused on removing one of the variables in order to make it easier to solve. So let's take a look at what we might do here. I look at the 2 and the 3, and I think I could turn those numbers both into 6s. Now, one of them needs to be positive, one of them needs to be negative, but that's doable. The other option would be to turn the 7 and the 4 both into 28. That's a little bit of a bigger number, and I might not like having to multiply 18 by 4 or 13 by 7, but they are different signs, which means I don't have to do any sign manipulation. In this problem, I'm probably going to multiply the first equation by 2 to produce 6x plus 14y equals 36. Now make sure you multiply all three terms. Everybody gets that multiplication. The second equation, I want this x to go away, so I'm going to multiply by a negative 3 so that I can get a negative 6x, a positive 12y, and that will equal a negative 39. Now guys, I made these problems up as I went. The answers aren't going to come out very pretty, but we can see how the 6x and the negative 6x cancel. We know that the equations are still valid from what we did over here. So as we add and get 26y equals negative 3, this is the way we would go about solving for y. Once we know y, we just plug back into one of the original problems to get x. So these are the conceptual pieces, why we're doing what we're doing. Watch the other video if you need to get some homework help that's specific to specific questions from the assignment. All right, good luck guys, and we'll see you in class.